Mario once again with MIA Microflight, another video, another day. This is going to be on some of these motors that I've been rewinding to achieve a particular RPM so that I can go direct drive on some of these smaller helicopters that I've had uh, back from the day. I'm talking about, helicopters that I designed back in the year 2000, like the Bumblebee, Housefly, the submicro helicopters. And so I have been on a roll to wind my own motors, to specifically address that need. There are helicopters that have come out in recent years that are direct drive. Direct drive, for those that are not familiar, um, is just a way to go directly with the motor to the rotor head instead of going through a gear system, a gear reduction, to use a higher RPM motors. Typically, helicopters, radio control helicopters have utilized high RPM rotors and then drop down that voltage or that RPM rather via a gear reduction, to the rotor. And that's just so that you don't overload the motor with a large rotor diameter. And so, but for this application that I'm talking about for some micro helicopters, I'm talking about helicopters with that type of rotor head. That's the two-legged helicopter, one of my own designs that I show in some other videos. And so I've been rewinding some of these motors that have gone bad. These are motors that I had for quadcopters that use up to 6-inch propellers. And so I've been rewinding some of these motors to achieve that. And in this video, I just tested this this particular motor here, and it's a slightly warm, not drastically too warm or too hot, and that's what you want, for a motor. I want something that's going to remain cool, and that's just a balancing act, of a lot of parameters here. I have written down some of these parameters here. If you want to just take a look at what I wrote here, you can study that. But basically, I am using a watt meter that gives me the voltage, the current, the wattage, and also I'm using this old Turnigy tachometer to measure the RPM. I just measured about 3,000, a little bit over 3,000 RPM on this rotor, which is I believe that's a 9-inch 9x6 propeller. Typically, that rotor that you see on the helicopter is about 12-inch propeller. So this motor should kick in. It'll work, but I want something with that's going to remain cool at 8 volts. My target is 3,000 RPM at 8 volts, 2-cell LiPo, and so I have been doing some calculations, and I'll be doing that next.